Yep.
All right. Well, first, thank you guys very much for having me. If you can see, you might see my breath in the camera. I'm up at Hickory Run State Park, about an hour north of me, for Pennsylvania QSO party this weekend, as well as activate this park with or without bears. When I came here, they warned me yet again that it's very high activity for bears here. So we'll see. Maybe they'll join in on the stream. So anyway, we'll discuss the N-Fed half-wave antenna. I've done this presentation a few times for local clubs, but this is the first time I'm actually doing it for you guys, doing it via Zoom. So everyone's known that the N-Fed half-wave has been popular antenna, and there is a few reasons why that is the case. Let me get to the next present slide. There we go. Perfect. Let me move this out of my way. Oops. Did I lose it? Hang on. Give me a second. There we go. Trying to make this smaller. There we go, so I can read it. All right. What is an N-Fed half-wave antenna? Many of you already know. You already have one. You're already using it out in the field for parks on the air, or even at your house as a base station antenna. Basically, an N-Fed half-wave antenna is simply a wavelength of wire fed at the end rather than the center, like a typical half-wave dipole. So when I say half-wave, it's not a random wire where it's pretty much any length that's not half-wave. Basically, with a random wire, we'll be discussing that in the future. There is special lengths for that antenna wire. But for the N-Fed half-wave, basically, as it is a single wire and end fed, it is very easy to set up, and that's why it's very popular. Often only taking a few minutes, which is great for doing parks on the air, and makes it ideal for portable operations, whether it's in emergencies or even using it as your base station antenna. A lot of people have trouble getting wire into the trees, so it's very easy to toss a weighted bag or a rock or a stick. I've went to a park on the air a couple times and I forgot my throw bag, so a stick or a rock comes in handy. Basically, the N-Fed half-wave antenna can be operated with a small counterpoise, although not completely needed, because if you don't use a counterpoise, your coax will be the counterpoise. And that's only if your SWR or the tuning of that wire is not resonant, or about 1.3 to 1.5 SWR units. I've noticed that because a lot of people have been using my antenna as well as the K6ARK antenna connected directly into a radio, primarily, obviously, the QRP ones, where you're not pushing 50 to 100 watts of power through it. So there's not going to be much issues with any type of common mode currents coming back into your radio. Basically, the lower end of the antenna may also be grounded as an alternative to reduce static noise. This can be done if you have QRM in the area, like a neighbor has a sorry, I just heard a gunshot out there. Just heard basically just sorry about that. But it's, if they have a solar panel array next to them, or, your wife has a nice, beautiful plasma TV and it creates a lot of QRM, this can help alleviate it. But certain noise generators, especially, some Chinese appliances, will definitely overrule that. And on to the next slide. Oh, this is where it gets fun. I didn't want to throw too much math. This is what I told my club and a few others. So basically, N-Fed and half-wave antenna basics. We are all familiar with the center-fed dipole antenna, which is basically a half-wave, and you cut it in half and put it on one side using one of those binding posts. Those are very popular. One of the first antennas most people use. Basically, in free space, that antenna actually represents an impedance of, I forgot to fix that, presents an impedance of 72 ohms to the feeder, and this means that it provides a relatively good match to the 50 ohm coax cable, which your radio loves to see. When the feeder is connected at the end of the half-wave antenna, the situation is quite different, though. Here, the feed impedance is much higher, and to enable a good match to be made with the 50 ohm coax, you can use like a balun or a transformer. Other people call it a matching device or matching unit, which is definitely required. Otherwise, it'll have discontinuity and power will be reflected, which you definitely don't want in radio. Basically, to provide the match at this point, a transformer, that's what most people call. You can call it a balun. There's different terms for it. Is normally used, and this gives the impedance transformation. Typically, a matching transformer transforms the impedance of the wire from a value of roughly around 1800 to 3200 ohms at the end-fed half-wave feed point down to the 50 ohms that's needed. And the reason I put a value of 1800 to 3200 ohms is there's a wide variety of end-fed half-wave transformers. And basically that's what it does. It transforms that high impedance down to something your radio loves to see, and that's close to 50 ohms. Any questions so far? Nope. All right, hang on one second. All right. And this is basically a diagram of what an end-fed half-wave antenna looks like. Let me see if my mouse goes on the screen. Can everyone see my mouse moving around there? No? All right. Down at the bottom, there's a 50 ohm coax cable that goes into the transformer. So two pumps there. So there's two primaries and 14 secondaries. Basically, the primary goes through and winds around a little bit, and it goes from the center connection all the way around and also goes into the ground. You also have the capacitor at the top. And obviously, if you want the counterpoise as well, if not, your coax is going to be the counterpoise if it's over about 1.3, 1.5 SWR. And then obviously you have the end-fed half-wave length antenna. So for about 40 to 10 meters, you would use about 66 to 67 feet of wire, depending on what you want to do. If you want to do CW, digital mostly, you're just a gangbuster on CW, banging out lots of contacts on CW. You don't want to do voice at all, so you'll keep it a little long, like 67 feet. If you're doing SSB and you hate CW and don't want to learn CW, and that's the reason why you never did ham radio for a while, is because you don't want to learn or do that with the testing, then you would shorten that wire a little bit down to 65 to 66 feet of wire for the 40 through 10. Let's go to the next slide. All right. Types of end-fed half waves. And you're probably yelling at me, Matt, a 9-to-1 is not a half wave. Yes, that is correct. I just want to put that up there as a reference point to show you the ohms of impedance. So a 9-to-1, which is I call a random wire, basically certain lengths that are not half wave long, and that is 450 ohms of resistance or impedance onto that from the wire. 16-to-1, which is popular for a terminated end-fed or terminated, or folded end-fed. Those are great. 800 ohms impedance. Popular one that is people are building it at clubs. I know the Washington Amateur Radio Club built one, and I talked to the president over there. This was about 2.5 years ago, and 36-to-1 end-fed transformer, and it's 1800 ohms of impedance. With that one, it's actually a lot wider bandwidth on 80 meters, which is really interesting. But then you have to put, I'll show you in the future slides, I think I have a demonstration on that, where you have to put a capacitor, and I believe also a resistor halfway through the wire on there. So it creates like a little tension point that could, possibly break on there. The most ever popular 49-to-1, the end-fed transformer is 2,450 ohms impedance. 56-to-1, that's a decent one for especially for the higher bands, and that's 2,800 ohms impedance. And another good one, the top three in my opinion, is the 64-to-1, which is 3,200 ohms impedance. The one thing very interesting about the 64-to-1 is you can actually utilize that more, actually better, for having a inductance coil near the end of that. And I'll be showing the inductance coil on a future slide. And that basically shortens your 80 through 10 down to a little bit over the length of a 40 through 10. There we go. And then the length of a multi-band wire for low SWR on the harmonic. That's the wrong spelling. Never mind. Harmonics, the impedance at the end of the antenna to 1800 to 4000 ohms, knowing that the impedance ratios needed to match the end-fed wire to our 50 ohms, 50 ohm feed point should be 36 to 64 to 1. This basically match is useful provided by a broadband transformer built using ferrite toroid. So ferrite is the good mix. People have been testing iron core ones, and those are mostly used for building like an Urshi, the Hawaiian designed 9-to-1 transformer. Not good for building end-fed half-wave transformers. Any questions? Nope, none heard. All right. Okay, the common components of an end-fed half-wave transformer. Basically, this is what's used to build them typically. A ferrite cord, like I said, typically a 43 mix. Some people have been testing out 52 mixes, anything like a 31 or a 61 core. Those are more for suppression. So like a 1-to-1 choke, you don't want to use those for an end-fed half-wave. Iron cores are out. People have tested them with very mixed results. Obviously, you can use enameled copper, not 100% needed. You can use Teflon coated stranded wire, but the enameled copper can handle a lot more power, and especially if you're using thicker gauge wire. So anything for if you're doing like kilowatt stuff, you want to do at the very least 18 gauge and up. So like 18, 16, 14 gauge enameled copper, which if you have arthritis, don't even try because it's a pain to wind some of those cores. I know. Then also, obviously, a ceramic disc capacitor. You can use a ceramic disc capacitor. Silver mica is very good if you can find them, especially with the temperature. If you're transmitting a lot of power, it's going to heat up. So sometimes it's not going to handle that well. But typically, most everyone's going to be using the ceramic disc capacitor, typically 100 to 150 picofarads. Obviously, an enclosure. Some people can use an enclosure, or you 3D print a winder and put it on top. A lot of people like that. It's easy, simple. The problem is when you're out there and it's raining or moisture, it gets in there and your SWR gets all messed up. I've had that when I built my own on there, when I bought one on there years ago. And it's not good for field day because, when the temperature changes overnight, gets moisture in there and you're having issues. So a nice closed enclosure is ideal. Obviously, bulkhead RF connector of your choice. So you can do an at BNC. That's my favorite, but I know a lot of people like the SO239s, and I've got requests for N-type connectors. N-type and SO239s are more for higher power applications, 100 watts or even more, like 2 to 3,000 watts on there. And obviously, stainless steel hardware. You don't want it to rust out there. So don't chintz on that. It's not that expensive. And obviously, with the enclosure, you want to seal it, in my opinion, going back to putting one on top of a winder. If you're out there and it's raining, it will change your SWR because moisture and water will get in there. So that's why I typically seal all my end-fed half-waves or any transformers I make. Same with my antennas and other companies like Ballon Designs. They make really good antennas as well. Okay, off to the next slide. There we go. End-fed half-wave designs. You do not have to do the crossover. It's not 100% necessary. It's just to get the wire to the other side. I personally don't do the crossover. So the first picture is a 49-to-1, 2 turns primary, which is the red wire. So 1, 2. And then you count those as well when you do across to the other one. So 1, 2, and that's 14, 2 to 14. And square root of 7 on that is going to be 49. So I don't like the crossover. It's not needed. And spacing can help. If you do build your own end-fed half-wave, build it with spacing. To test an end-fed half-wave, just going to go into this, you could put non-inductive resistors. So for a 49-to-1, you can put 2,450 ohm resistors across, ideally non-inductive, so you're not having any skewing of the results, and pop on your Nano VNA or Rig Expert, and you will see the SWR dips and everything on there. And the really neat thing is, if you squeeze or spread those windings, you will see differences in the bandwidth as well as how deep your dips go. The deeper the dip, obviously, the lower SWR. And when I did a class, usually I do this presentation, and then like that evening or a week later, we do a build night when maybe we'll figure something out with you guys. And a gentleman put them together. He was the first one done, and he had them nice and tight, like I told him to do, because that's what I found to work the best. And I said, okay. He goes, oh, it looks great. The SWR looks fantastic on my N3VAN. I go, okay, we'll start spreading those windings besides the primary ones. And the windings, when he started spacing them, the SWR started changing, as well as the dips and the bandwidth level. So it's interesting to experiment. That's what's great about the hobby. But as you usually see on most designs, they are spaced evenly, or as evenly as possible. And that helps with dissipating the heat, but it's not necessary and can negatively hurt your transformer. Next popular one just has 2 extra windings. So if you count, if you can even see the screen, I'm not sure how big your screen is over there. So it's 2 turns primary, 16 turns secondary, and that is a 64-to-1. And if you want to build a multi transformer where you have a 49-to-1 and a 64-to-1, you would just put a tap right there, like scrape it off, solder another piece of copper, enamel copper, and then go to a different lead or to a switch, and then you'll have both, best of both worlds, a 64-to-1 as well as a 49-to-1, which works great. Now, the next one is a weird one. The design is unusual. Some people don't even know how to build it. They build it wrong, and that is a 36-to-1. Almost looks like a dipole, but it is not. So it's basically just your counterpoise lug on the other side. As you can see, the counterpoise lug is actually on the left-hand side. It goes down to the coax sheath, or the bulkhead ground, which is basically just a lug there that they connect to. Right, next slide. There we go. The Easy Mat, the NFED half-wave wire length. Basically, it's 140. The formula is for feet is 468 divided by the frequency you want. So you would do 468 divided by 14.150, or center of a SSB band, whatever you want. But I always add a few extra inches, like 4 to 6 inches, just in case you want to, undo some of the wire and get into that more of the digital dips in the digital band, digital portion of the band, as well as the CW, if you want to get crazy there. Basically, as the name indicates, NFED half-wave antenna is a half a wavelength long on the lowest band of operation. So for 80 through 10 without a tuner, you would need about 130 to 133 feet of wire. A lot of people start with 132, 133, and this way it gives you the option to tune it and fold it for, like I said, the SSB portion of the band, or CW portion of the band. Basically, however, the physical length is slightly different, and this is where when people cut their wire or do the numbers and then they cut it perfectly and they go, oh, I think I got it, it's awesome. They go out in the field, put it up into free space, and it's wrong. It's because there's a thing called velocity factor, as well as putting this wire into free space, and it does change the dynamics. And that's why I always recommend, if anyone's building an NFED half-wave or purchases one from me or someone else, that they cut the wire a little extra long. And if the dips are like beyond the band or in the beginning of it on a Nano VNA or the Rig Expert, that's great. That means you can shorten it. If it's too short, then you got to use butt connectors. It gets ugly, and it's going to be a failure point on that wire where you have to add wire to it. In the last paragraph, basically a variety of figures are used for determining the length of the wire, half-wave wire antenna. The factors used in the formula below take into account the wire, antenna wire end effect, as well as the thickness of the wire, assuming typical wire thickness is used. So if you have super thin wire, it's going to change the dynamics of how long your wire is going to be. It's actually going to most likely going to be shorter based on my doing this a lot and experimenting. And then you got the British one. The first one is for meters, 141 meters over the frequency. So if you're in British or Canadian, use that one. And then 468 over frequency, if that's what we do here in the States to do it. I usually do the meter ones because it becomes more accurate. Because obviously, 40 meter band, all the other things, it makes it a lot easier. All right, next slide. All right, NFED half-wave power handling. There's 2 factors with NFED half-wave power handling. One is the core size, the mass of the actual ferrite core. as well as the enamel copper. Someone could take that huge one at the bottom, which is 2.9 inches in diameter, bigger than the normal one that everyone uses or sees, and that's the 240 core. And if they put the thinnest wire on there, like, 20, 26 or 24 gauge enamel copper, you're going to reduce your power handling because there's not much power being able to handle that. The core will be able to saturate it and not heat up as fast, but you're going to be limited. It's going to be a gigantic resistor anyway. So popular for QRP is 100, the FT 140 at the top, the nice little donut, small one. 140 43 is good for up to 100 watts single side bands, 70 watts digital. Give or take conditions. If you're in Texas or in Pakistan, where I sold an antenna, it's going to heat up fast because the ambient temperature is, going to greatly affect that. But up here in the Northeast, like us, I'm thinking I'm like, what was the temperature here? 46 right now. So 46 here, I can run a lot of power through that, heat up my nice little tent here, and have no issues with dissipating that heat. The most popular one, like I was mentioning before, is the 240 core, the FT 240-43. It's good to about 450 on SSB. You can also stack them. A lot of people do. The best thing to do is stack them using super glue. These ferrite cores love super glue. You just got to make sure you align it perfectly. And then once you put them together, it's very hard to break. You'll actually break the core. I've done that before. It also handles up to 200 to 225 watts on CW and digital. And the Big Daddy one, which there's actually a new one that just came out, which is, I think, 4 inches in diameter. But this one has the significant, more mass than that one. And that is the Ferrite FT 290-43. That's good to easily 1,000 watts SSB, the kilowatt, as well as 600 watts digital and CW, stackable as well. The nice, really cool thing about this is you can actually, baby these things. You could put that FT 140 core inside the 240, and that gives you more mass, thus a little bit more power, which is nice. That's what I do. Other companies do with that. I think there's a British company, HF Kits, does that as well. And you just put a little super glue on the side of the one that goes in the inside. So like the FT 140 will fit nice and snug inside the FT 240. And there you go. A little bit more mass, a little bit more power handling. Wrap it with, if you're doing more than 100 watts, I'd recommend doing probably like 14 gauge enamel copper, but trying to bend that through the center of some of these cores is a little tough. There we go. Oh, I try to make funny on the, we need more power. So good example, great antenna. A lot of people have this to start or use it as your base station. And this shows you how much power handling these cores can handle. So there's Scotty asking for more power. And let's see, basically by stacking the ferrite cores, you increase the material and thus the power handling limit. So there's the 2 stacks of the 2.4 inch or the 240 cores, and that's what's used in the NFED. My antenna is NFED half wave 80 through 10, 1 kilowatt. Then they upgrade to the 2.9 inch diameter, the 290s, the FT 290s, and that goes into their 2 kilowatt handling one. And to be honest, these actually handle a little bit more power. They're very conservative with their numbers, like I am. And then the last one is a triple stacker. It's like, one of those triple stack burgers you get at Wendy's. So this one handles their 2K plus, usually roughly around, 3 kilowatts on there. Obviously, they're using thick, nice quality enameled copper. Most likely, I haven't opened one of these up, but I think it's 14 gauge, maybe 14 or 12 gauge enamel copper. There we go. And we're almost done with the slides, but deploying an NFED half-wave antenna, this is what's great about it. There's so many different avenues to set these up. If you're limited with trees, right now I have tons of them around me, but you can do the standard inverted V where you have the transformer down near the bottom about 2 to 3 feet off the ground, put a mast in the middle or have a tree in the middle, and you pop it up there in the center of the wire, and then the other half goes down. Keep it roughly the same off the ground, a little higher if you want. And that's also, this is great for doing DX with an inverted V. Number 2 is my favorite, inverted L. You can do this in parks where they don't really allow wires in the trees. Yes, I break their rules. I've done that before down in Shenandoah National Park in Virginia. Park ranger walked by. kids were walking underneath my wire. They didn't know it because I went up a tree, across, and then down a tree. They're not going to hit that. Park ranger asked me what I was doing. I said, I'm just activating the park. And he didn't ask, oh, where's the antenna? Because he wasn't a ham radio operator. So, and number three, if you have enough tree or a mast, a vertical always works really well. They call it an aerial or a Z-axis wire. Sloper, this is everyone's favorite for doing parks on the air. I call it the lazy man setup. I'll be doing that tomorrow probably. And that is basically having the transformer. They do it the opposite. They have the transformer up a mast and then sloping down. I do it the opposite. Most people do, where the wire is all the way at the top of the apex of a tree or wherever you throw it, however far you can throw it. And then the transformer is about, 2 to 4 to 5 feet off the ground. And that works great. Some people even just lay the transformer on the ground and it works. Not ideal, but it does work. And then obviously the standard horizontal one, those are great for setting it up at your house, permanent, or out a second story window. But just remember, each one of these, except for maybe 2 or 3, I think the inverted L and sloper and the V will change the SWR, and you have to adjust the wire length at the end. So you just loosen up that wire, lengthen it or shorten it, depending on where the dips are on the wire there, on the Nano VNA or your rig expert. See, next slide. The debated one. Counterpoise, the often heated debate over. What's that? Oh, all right. The often heat.
I'm going to pop this because he's picking mistakes.
Can I go?
All right. The often heated debate over if an N-Fed half wave needs a counterpoise or not. Some people plug them directly into their QMXs, true SDXs, even like I have my ICOM IC705 with me, actually a few radios this weekend, and I will plug it probably directly in there. It is often mentioned, though, that an N-Fed half wave needs no counterpoise or radials to work, and it does, depending on the power handling and if it's resident on there. But in practice, this type of antenna is often used in the field with no counterpoise, and it performs very well. You can also clip one on. The new antennas I've been building have a counterpoise lug, so people can always add that on there. But you got to remember, if you're doing power over 20 to 30 watts, something's going to be the counterpoise, either your coax or, a wire on there. And the ideal length of the counterpoise should be, obviously, if you're ham and new hams, it's 0.05 of a wavelength. Next one is grounding. Grounding needed, not necessary, but it will definitely help you with QRM or any type of noise, especially if your vehicle fuel pumps kick on and you're doing parks on the air. And that will definitely ruin your day because your noise floor will quickly rise. Right, next one. Oh, there we go. N-Fed half-wave loading coils. I started delving into this. I built a few of these and shipped them to people that wanted it. Don't offer it yet, but a lot of people do. It's popular over in Europe when their space is limited. Basically, it's just I call it the shorty 40. It turns a 20 and a 10 meter antenna. That's the bottom one on the bottom. To 40 meters if you add that 34 microhenry inductance coil on there, and then 1.5 meters of wire. So, a little over seven and a half feet of wire. Most popular one is the 40 through 10 plus the 80 meter with that inductance coil, and that's the top one. So you tune it. You have to always tune the wire first from your transformer to where the end of the wire is for either 40 through 10 or 20 through 10 first before adding that inductance coil, or it throws everything off. So with that, you just, wind a PVC pipe, with, I think for that one, the top one, it's going to be 18 gauge enamel copper, or you can even use the wire itself. I usually use the enamel copper, and you just wrap that, and you can use LCR meter to test the microhenries on the coil, and then just add the 6.5 to 7 feet of wire at the end of that, and it works well. But the problem is your 80 meter band is going to be very short, so the bandwidth on that is very small. It's great if you're just doing AM digital nets. Like on Sunday, I'll be doing the PA narrowband emergency management net on there, and it's perfect. Just set it up. It's great for limited space, but again, you do sacrifice some bandwidth on the 80 meters with when you're using the 110 microhenry coil, or same down with the 40-meter band when you're using that 34 microhenry coil if you have a very short wire of 20 through 10. Okay, next slide. There we go. Commercial end-fed half-wave kits. Kits are great because you get to learn how to build something. You can see, if your design's a little bit better, your windings are better, or you completely fail and you're horrible at soldering and you're just going to buy one. They're great. It's a great learning experience and it's fun. And I greatly encourage everyone to at least get one of these and build one yourself, or even buy the components and build them based on the numerous videos on YouTube. One of the ones I always started with when I was doing beginning of POTA was the K6A or K1. It looks like the little mouse on the top. Basically, a toroid is on a circuit board, very small, and it will test your soldering skills greatly. They're great. I had two of them, but the problem was I broke one right before an activation with a friend, and that put me in a bad mood for doing an activation. They're great. But just make sure you put it in some type of hard enclosure to protect it. Next one, we're going to go down. We're going to go that coffee and ham radio antenna. That's a nice one. Builds on the right winder, but you got to remember what I mentioned to you about winders. If you leave it outside, or if it's raining or gets moist, it does change your SWR a little bit, and that can be a pain in the butt. They're great because you can pop the wire on the winder, but without it being enclosed or sealed a little bit, any type of moisture that gets on the soldered connections is going to have issues. My next favorite one is the QRP guys in the upper right-hand corner. And that's a great one. That's a different winding. It's a 16, and it's a 16, 64 to 1, sorry, 64 to 1, but wound 3 turns primary, 24 turns secondary. Actually, sorry, 21 turns secondary. And they got a little capacitor there, works great. It's on that nice little not 3D printed, but on a circuit board winder. And another good one is the bottom one, which is the KM4 ACK wire winder. I'm not sure if he still has those out there. That's a good one. But the key is you got to put some type of sealant on the soldering joint so moisture doesn't get in there and ruin your day for activations. There we go. They also have the ARL kits, which are nice. Those are sealed in there, but those are pretty large. And I think HF kits, supplies that for them. And it works great, but it is kind of large and not really for portable use. All right. And then you got the commercial end-fed halfways from relatively inexpensive to, oh my God, that's expensive. So or on Antanium, you got the standard one, which I started out with, which is the My Antennas. They got the little inductance coil on the front. That's for 10 meters or the higher bands on there. And that's usually mostly used for permanent basis. Then if you go over to the right, that's going to be the Chameleon antennas. I think that's the light end-fed half-wave sloper, and they also utilize the same inductance coil in the beginning. Proven design. They do it a little differently. They do it what I do. I put the heat shrink tubing over that to prevent the wires from moving, as well as protecting them. And then the sometimes unattainium on the far right is the Pactenna. A good friend of mine that I got into the hobby. He actually gave me one of those years ago, and a dentist that retired, and I love that Pactenna. It's great, portable. They do seal a little bit better, but I have seen moisture get in there and cause some havoc on there. Then the bottom left, that is, I forget his N6SAB. I think that's his antenna, and those you can get on eBay, Etsy, and those are really nice. They're sealed in a case, and they're helpful. And then obviously, last but not least, is mine. I use the nice little Hammond case and close it using the acetone to melt the ABS plastic case, so it creates a nice little cohesive unit on there, and also put some goop on the BNC or SO239 connector and the lug at the top, so prevent any type of moisture or water from getting in there. like we're going to have in the next few days. There we go. All right. That is it. Any questions? Yeah. Can you guys hear me?
Yeah, the mic is still muted at the library in Zoom. If they can hear
Yep.
me.
Mike still muted.
Yes, I can still hear you.
All right, guys. I can't hear you there. I can't unmute them. I can only ask to unmute them. there we go.
Now. All right. Any questions from anybody? I'll keep it working like anybody that's got questions.
Very nice.
No questions? All right. Well, Matt, thank you so much for being with us here tonight. Good stuff. Very much appreciated. Great.
Oh, thank you very much.
As well.
Nice. Thank you very much. I'm going to figure out why my buddy heater's not working. I got a propane tank, but I'm going to do that. But if you guys have any questions, shoot me an email. You can find me on QRZ N3VAN. And I'll be glad to help you. Even if you have a vertical antenna, not a wire antenna, I like helping the ham radio community. So thank you guys so much.
Thanks, Matt. Thank you, Matt.
Thanks, Matt.
Take care.
All right.